So let's continue. Good afternoon to all of you. Now we'll do module 17, how to build a small network, okay? Which is actually our last module of CCNA-1. So we'll look at how to implement a network design for a small network to include a router, a switch, and our end devices. Okay, so let's start. So what are the devices in a small network? Okay, some of the devices that we have, okay, first of all, is we have certain topologies that we follow. If we are having a local area network, the best connection that we have is an Ethernet connection with one outgoing WAN connection, wide area network, which is usually connected to a router, okay? And that connection is through high bandwidth fiber optic or even DSL connection or cable connection, okay? Your Ethernet connection, if it's a small network, it's very easy to design. But the moment the network becomes big, because corporation and enterprises grow, so you should have a way to make your connection scalable. That means you should be able to make it bigger. At the same time, you shouldn't compromise maintenance, security, and troubleshooting. Okay. If you have got a big network like Curtin, if you have got an ICT department, they take care of the network. If you have got a small organization, then you can subcontract your ICT issues to another company. They will come and take care of your networking. Okay. So when it comes to large networks, okay, there are certain requirements that they have to ensure that the clients get. Large networks, an example is what we have at Curtin. It's a very large network. Okay. Planning has to come into force. They have to first plan. They should always document. Okay. They have to make sure that when you design your network, especially a large network, you have to have certain things in mind, like what would be the cost, or what kind of speed are we looking at? What is the requirement of this office, of this network? What is the growth factor? Because scalability, as I told you, is very important. What kind of operating system is going to be in this network? What are the features and services that we're going to give? Are we going to have licensing fees? So we are going to go for Windows, or is it going to be, a Linux system with perhaps a lesser fees, or it's going to be a certain proprietary software? All these kind of questions you should ask, okay? But the most important thing you should remember is when you start small, you should have room to make your network scalable, okay? Even when an architect designs a building, one of the things that they always think is, where do we put the networking equipment? Where does the wire go through? It's a fact of life for the past 30 years, okay? The cabling, what is cabling? It's not just electricity, power cables. It's also communication cables, data cables, okay? Your UTP cables and so on. If you're designing a network, okay, you should ask yourself, what IP addressing scheme are you going to use? Is it IP version 4? If it is an Ethernet, Is it IP version 6 or is it going to be both? Okay. Are you going to do subnetting? Okay. So again, plan, plan, plan. And when you plan, you design. When you design, you have got things on black and white that only the network administrator will see. Okay. And only the network administrator and the immediate generals under him will know. Not everybody else will know what your network is. Okay. It's very important for you as a network administrator not to share the blueprint. That means the topology of your network with outsiders, because a threat actor can then know how to attack that system. Okay. So planning and documenting is very important. Another thing that you should know is when you design your network, always have in mind redundancy. A few weeks ago, or rather a month ago, I don't know whether you experienced, we couldn't access Moodle. And students were complaining, and even lecturers couldn't access Moodle. So there was an issue. There was a failure of one networking component. I will not name that component. There was a failure of that networking component, and we didn't have a backup. So that was surprising. We realized that there's no backup. Okay. Now look at this topology. The server services, there are 3 backups. The switch, if one fails, this one will take over. The router, if one fails, this one will take over. So design something. Design something which takes into consideration redundancy, especially in physical redundancy. So if something fails, the other one can take over. So remember redundancy as network administrator. Always when you are a network administrator and you want to do redundancy, the main issue would be cost. Your CEO will say, no money, no money. Okay. And then you put that black and white of no money, no money. When something bad happens, then when you go into that shareholders meeting, you show the email. See, I have asked on such and such day, and this person said, no money, no money. So you have to protect yourself. Okay. You say, I have asked, I knew such a thing will happen, and I have asked on such and such day that I want this installed system, this software system. But the CEO said, no, there's no budget for it. So you cannot just blame me for the failure. Okay. So you have to be proactive, always steps ahead to make sure you protect your network. Okay. It may be very daunting in the beginning, but after some time, it will be really, really interesting. Who is that? Could you please make sure that you don't disturb the class? Switch off your network, your microphone. Thank you. Next. You should also plan and see which chunk of the traffic takes the most of your bandwidth. Usually, the voice will take higher priority. Okay. Then perhaps your SMTP, then perhaps instant messaging, then your FTP, and so on. Okay. So you have to know how you share your bandwidth in your network. Okay. So that the quality of service is perfect. Okay. So what are the applications and protocols on a small network? In a small network, we have got network applications that directly work on our network, certain applications which are by design network. For example, our email service is a network application. Besides that, we also have certain applications which are not networking applications per se, but they use networking services. Okay, so we have to know which one is which. And we have to know what are the protocols that we have. Okay, if we have Telnet, don't use Telnet, use SSH. If you have HTTP, don't use HTTP. Ensure everybody in the company uses HTTPS. Okay. What are you using for the company's email? SMTP. If you're using the post office protocol, or are you using IMAP? Okay. If you're using file transfer protocol, better use SFTP. Okay, because it's encrypted. Are you using your DHCP server? Which one is the DHCP server? Which router is serving as your DHCP server? Okay. What is your DNS? All these things you have to know. Okay. Which location and where. And you may not have a separate computer acting as a separate server. Sometimes you can have one computer which is overwhelmed with all the services, okay, which is also not wise. You should know how to differentiate and make sure that different services are on different computers, okay? Although if you have it all on one server, you should have a backup. Again, redundancy. Okay, you should have a backup of that server. So if that server fails, the other one will take over. So the network protocols comprise the fundamental tool set of a network professional. They are responsible for communication, for messaging, for syntax, okay, information, how messages are sent, and expected response, how they interact with the lower layers of your OSI model, and so on. Okay, so many companies actually prefer to use an encrypted format, SSH, SFTP, and HTTPS, to make sure that everything is secure. So it's like a game. The network administrator will always try and make the network more secure. So at the end of the year, when the network administrator is going for their appraisal, they will tell, for example, this is what I've done this year. That's why we didn't have any attacks. Okay, so I deserve this promotion, or perhaps I deserve a bigger bonus because of me. Your company is running. I've told you since the beginning of this semester that the network administrator of any enterprise is a very powerful individual. And that person can make your life miserable if they choose to do so. Okay, so you have to be very careful. In a company, you have to be nice to the network administrator. Okay. These days in our enterprise, we do a lot of voice and video applications. Think about now, what are we using? We are using a WebEx system. Okay. If we were on a network that did not have a high bandwidth capacity, do you think you could log in? Do you think I could conduct this class? Of course not. Okay. Similarly, in the network, you have to ask yourself a question: what kind of infrastructure does this company need? Is it going to use IP telephony or voice over IP? Voice over IP, let's say if you just install Skype, okay, that one is okay, but then the quality is not the same as IP telephony, okay? Are we going to use a lot of real-time applications in our system? Are we going to use RTP or RTCP? So these are some of the questions you have to ask. And based on that, you will access the network, the internet plan that is the best for you. Now, when you start a network, when you go and work for a company, usually the company always grows. So when you go to that company, after 1 year, that company is not the same. When I came to Curtin, the network was very small. And every year it becomes more sophisticated and more sophisticated and more sophisticated. Okay? So your network will only grow and change. And the devices joining it will always become much more sophisticated. For example, 10 years ago, there was no such thing as smartphones joining the network. No. Every time the policy changes. Now, just 2 years ago, yes, you can have your smart devices join the network. Then came another policy that every person can have 2 devices join the network. Then perhaps 3 devices and so on. Okay. So all these policies are updated, taking into account scalability, because the network always grows. So growth is a natural process. Okay. You have to ensure that you ask several questions. First of all, document what changes have taken place. Ask your technician, what is the problem? What is the issue? Which staff computer is generating an issue? Why? Go and check. Find out by doing a distant audit of that person's computer. What application is that person running? Which YouTube channel have they checked out? Which website have they gone to? What files have they downloaded? The network administrator can do all these audits. And based on those, we'll go to the CEO's office and say, hey, this guy has been accessing suspect websites and downloading suspect materials, and it's affecting my network. And then the CEO will go to HR and say, hey, we have a problem. And then they will call this guy, and then they find him guilty. That's it, you're fired. Okay? That's why I say network engineer the administrator have to make sure that the network is secure. Okay? Because your credibility and your reputation is on the line as an administrator and engineer. I mean, the network engineer. Okay? I use the term network engineer and network administrator interchangeably. Okay? So you have to be very careful. You have to make sure your loyalty is only to the company and to the network, okay, not to the people who are working there. You should have an inventory of all the devices in the network. Okay, suddenly a switch goes missing. How can it go missing? It was under lock and key. Who has the key to this room? Okay. If a router has suddenly stopped working, which happened a few weeks ago, do you have an immediate router to replace it? When I say immediate router, that means it should also have the same setup as before. If you have to sit down and again give its commands, what are the routing protocol, you have to set up all the commands. You have to set up a DHCP server, how much time it's going to take. Okay, you cannot say I'll do it on a Saturday or on a Sunday. Saturday and Sunday, students are still going to access the system. You haven't planned. Okay, so something wrong. So you should have an inventory of all the devices in your system. If one switch goes down, immediately here, I've got a replacement switch, go and fill it up. Because you are liable at the end of the day. The CEO will come and tell you why this place doesn't have a network connection for the past 2 days. You say, hey, I have asked you for the past 1 week that I need these equipment, and you haven't answered me. You haven't given me budget for buying new equipment. These are my backup equipment. Now that something is down, I don't have the devices. The devices that are in storage right now do not do their job. I need a new equipment. Okay, so you have to do an inventory of all these things as an administrator. It's part of your job. At the end of the year, you have to do a budget of what are the things that you're going to need in the next year. Always have a budget of a higher budget of the things that you're going to need. Okay, you should foreshadow what are the things that you will need. Okay, you should do a proper traffic analysis. Okay, run Wireshark and check where the traffic is the highest, on which domain, and on which device. Which person's computer is using the highest? What application are they running on their system? Okay. A few years ago, I downloaded a software which was a cryptocurrency software, and I wanted to test because one of my FYP students was doing a blockchain FYP, and I just wanted to do a few tests. And after some time, I got an email from the ICT, this is a true story, from the ICT manager that, Foad, why are you running a cryptocurrency software on your workstation? We are going to report you to HR. Please explain yourself. And then I explained that I installed the software because my student is doing a blockchain application, and I just want to test a few things and do a few readings. And after I did that, I immediately uninstalled it. Then they were satisfied with my explanation. They sent a ICT person to come and check my computer to make sure that there are no, software which is remnants of that software. Make sure that everything is clean. Yes. Okay, so these kind of detailed check you have to do. Okay, it isn't an easy job, but it's a very interesting job, being a network administrator. Okay, so some of you may be interested to go for this, especially when you do your CCNA-2. The things that you learn is so interesting. The controlling of the network. Okay, you will know the real power of the network administrator. Okay, how you can block one person in the network by just giving one command on the router. Okay, and when you do your CCNA-3, if you really like it, go for it, because it's a very rewarding career. Okay, yes. You should also do a protocol analysis of your network. Okay, try and find out which protocols are used, the highest, what is the network utilization? Is it is it because of internet? Is it because of people using perhaps YouTube a lot? Is it because people are accessing a certain website, which is causing too much of drain on the bandwidth? Okay, so you should have a detailed study on different segments, okay, of your network to make sure that you study the details. Like if somebody just comes and attaches a switch to the network, what is the result of that? How do you find out who is doing something on the network which is suspect? Okay. Are you using a proper analyzer that studies the network? Is Wireshark enough for you? Or do you need something more sophisticated that you have to pay for? Okay, all these things you have to know. Certain things like you have to know what is the network utilization of your network. There are certain commands that will give you a certain snapshot. What kind of operating system you're using, what is CPU utilization, what is RAM utilization, network utilization, drive utilization. On a server, on a Windows system, on a Linux system, these are very easy to find. You see, if you can go to your CPU, your task manager, you see it shows me my CPU, okay? It shows me what kind of CPU I have. I'm using an i7 2.20 gigahertz system, and it's showing me. See, when I open Microsoft Word, okay, when I open Microsoft Word, what happened? In Word. When I open Microsoft Word, you see there is a spike, okay? So in your server, you should see, especially at a time when the traffic is low, when you're studying it in midnight, look where the spike is happening. From which network segment? Study your memory, okay? Memory, for example, here, I've got 16 gigabytes of memory, okay? And how much of constant memory is being used, okay? If it is constantly always high on my computer where I'm not doing something, that means there is a background application running over here. Try and find out what background application is running, okay? Which process is using that? You can study it, okay? Go to your resource monitor. In your resource monitor, you can study your overall system, your CPU, okay? The same is for Linux. This is a Windows system I'm using. Memory, how much of memory, your disk usage, all the disks that you have, your network usage, and which process is using the network, how much of bit they are sending and how much of bit they are receiving, which component of your network, okay? So if you have got a worm, it will clearly show which service they're using, what subroutine they're using, and then you can find out, okay, who is actually on your system. Besides that, we have got many third-party tools that can actually tell you what's going on in your system, okay? So these are some of the tools that we can use, okay, to find out more about our system. And based on that, just document and find out the details, okay? You know, some companies, what they do is they do not own their devices like computers, okay? They keep updating it like every 3 years. That is the policy. Next, verifying connectivity. It's very important for us, even if our network is new or it's an existing or it's a big network, you have to make sure that your components are properly connected, okay? And one way you have learned how to do it is by trying out the ping command. When you ping, you can find out whether you're connected to a distant device. And you have used ping in CCNA-1 very well, and you have learned how to use it very well, okay? A ping has got certain indicators, okay? If, for example, you get an exclamation, that means everything is successful. A period means the time rating has been passed and you still haven't got the message, okay? That means if you get a capital U, you're not, your destination cannot be reached, and so on, okay? The ping can also be tried out in extended mode, especially in our intermediary devices like routers or switch. You can type just ping, enter, and then you can enter your target device. Once you enter that, then it will give you detailed information about accessing it, and will tell you at the end whether access is 100% or not, okay? You can also use the trace route command, okay, which will tell you if you want to access, for example, a certain device, it goes through how many hops, okay? So over here, for example, I think I've shown you how to use trace route before, correct? Let's say a tracer www.google.com. Okay. Now, 1 hop, 2 hop, 3. You see, it shows me IP version 6 address of each router that I'm going through. The third one, it doesn't. The timing, you see? Yeah, request timed out. There. 6 hops, 7 hops, 8 hops, 9 hops for me to go to Google, okay? From my computer that I'm using right now to talk to you, okay? Now you can also try it out on your computer, okay? So you can also stop your tracer midway by typing Control-C, okay? So here, for this person, 4 hops to reach this, okay, computer. Here, what you can do is you can actually find out where the issue is in a network. For example, if you are trying to access a certain system, if let's say you cannot access, you see, request timeout, request timeout, request timeout, you can access this node, but after that you cannot access. So the problem is somewhere here or here or here. So how do you do that? You try and do a tracer from this section. If you can connect, that means the network is perfect. If you cannot connect, then perhaps the connection issue is between these two computers or perhaps between this. So you can isolate the issue by using a trace route command. Okay. Just like how you have an extended ping, you also have an extended tracer. In Windows, you can do an extended tracer with all the other options. Okay, we won't go into details of those options. There, in your router also, you can do an extended trace route. Okay, in Windows, we say tracer. In router, the command is trace route, and then you mention the target IP address that you want to go to. And then it gives you the details. Okay. One thing you have to learn, my dear students, is sometimes when you do a command like this, you know, getting the information here is okay. You see, when I get the information here, sometimes I need to record my information. So you have to know how to output to a file, okay? For example, the same command, what I can do is, let's say I go to my D drive. I have a folder called demo, okay? Now, what I do is the same command that I gave before, I give the same command, tracer www.google.com, but rather than getting the answer on the screen, I send the output to a file, okay? So I can say path to google.txt. So I save the result of this command to a file called path to Google. Now you see, it will not show the result over here, but rather it will save it to path to google.txt file. Okay? Yeah, it's doing a tracer and it is saving it in path to Google. The benefit of sending the output to a file is that you have got actual documentation. So now I can just type to see whether the file exists. You can see, yeah, There it is, path to Google. Okay, so just type path to google.txt. There, you can see your file. Or you can just read your file from the location here. This is the location, my demo. There is my path to Google, which I just created. Open it in a text file. Isn't this better to study it? Okay. And you have got the documentation. So all the commands, you can actually send a backup to a file and maintain a log of what is going on. Okay. With evidence. Okay. So that's a benefit as a network administrator. It would be nice for you to have a backup of everything. Okay. These text files will have information about everything, and later on you can actually use it for evidence. Now let's go to host and iOS commands. In Windows 10, actually, you can get information about your network by typing ipconfig, and you can get detail like MAC addresses by typing ipconfig/all. Okay. If you have got IP address from your DHCP server and you are a DHCP client, you can get a new IP address. All you have to do is type ipconfig/release and then ipconfig/renew. So you will be getting a new IP address. Sometimes, if I don't know whether you have experienced this, if you're using Streamix or if you're using Unify, sometimes you have got connection problems, and you call the agent, and the agent who's trying to troubleshoot will tell you, can you please type ipconfig/release, ipconfig/renew? Why is the agent telling you to do that? Because they want you to renew a new IP address from the DHCP. And then they will see whether this has troubleshooted your issue. Okay. In Linux also, we have got the same command, but then it is ifconfig. Okay, ifconfig. So I have an online Linux system over here. You see, ifconfig. Now it tells me, okay, what is my Linux system over here? There tells me certain addresses. Okay. I think my connection is broken. Okay. Yeah, it works. So ifconfig. Yeah, there it tells me the hardware address that they are using. Okay. So it can give me in Linux information about my connection. Okay. I don't see any IP version 4 address over here. Okay. If I want to renew my connection, perhaps, then I will be able to see. You see, I'm renewing my Linux connection now. Okay, now I can get an IP address. Can you see? Okay, this is the IP address that the Linux is using, and this is the subnet mask, and this is the broadcast address. You see? Okay. The reason it didn't give me earlier because I had the system just on, so the connection was broken. So sometimes you have to renew your connection. Okay. If you're using an Apple computer, also it's the same command, ifconfig. Okay. You can also find out host IP settings by typing network setup, list all network services. It will show you all the network services on your Apple. Okay. For those of you who are suffering and by using Apple. Okay. We also have the ARP command. We have tried the ARP command before. It tells us on our router, okay, or any other device, what is the IP address to MAC address binding, okay? So this also we can use. You can clear your cache, ARP cache, by typing net sh interface IP delete, okay? IP delete ARP cache. So it will remove the binding and it will create a new logical IP address to MAC address binding. Okay. Although in order to do that, you need a network administrator account. These are some of the commands that we have studied. Let's just go through them again. Show running configurations, show interfaces, show IP interface, show ARP, show IP route, show protocols, show version, and so on. Okay. So these commands you have to use as tool to solve your problem in next week's lab. If you want to use the CDP command, okay, this will tell you information about your neighboring devices. Okay, for example, a router, what are the neighboring devices? Over here shows CDP neighbor. So it tells the switch S3 and the connection is gigabit. Okay, it is a layer 1 switch. Okay, and it is this kind of hardware device. It is on fast Ethernet 5. The connection is on fast Ethernet 5. So without actually going and inspecting the hardware, okay, which in a big enterprise, it is very difficult to do that. Okay, you can just issue commands like this to find out more about your system. Show IP interface brief you have used a lot. It tells you information about your actual connection, the port that you're doing the connection. Some small troubleshooting methods, okay, that we can use to dispel difficulties is a certain steps that we can take. Number 1, identify a problem. Number 2, try and establish a probable cause of that problem. And then test by giving your commands and determine what is the cause of the problem. And then have a plan of action to solve the problem, verify your solution, and then document. Okay, and what was the result? Okay. So the more you have experience and the more you document and you keep studying it, you become a better network administrator, better network engineer. And when you become better at something and then you become very good at something, you charge a fee for that and you earn good money. So some questions you have to ask yourself. If in some situations, should I immediately escalate the problem and bring it to the attention of my CEO? Or should I just try and solve it and try to solve it within my own domain? Okay, these are some of the questions that you have to answer. Should I resolve or bring it to, escalate it to the upper management? If you keep escalating everything, the upper management will get tired of you and will say, this guy doesn't know how to solve his own problem. We have to do our work and we have to do his work as well. And then they'll say after your 3 months probation, sir, I think you better leave. I don't think we need you. Okay. So there should be a certain level of problem solving at your end. You cannot escalate everything. Then you just become incompetent. Okay. People just want to make sure that the network is working properly. You don't have to escalate all the details, the jargon and all that. That is your issue. You escalate something that you think you cannot solve. Okay. especially, if a staff is making an issue, rather than talking to that staff directly, you just bring it up with the CEO. Then the CEO will talk to HR, and HR will get rid of that. Will get rid of the issue. If the issue is not got rid of because of the staff, they'll get rid of the staff. And then your network is safe. Okay? Certain things you have to have experience, and then you understand it better. Another command you can try out on your iOS switches or routers is the debug command. It allows you to give you information about all the processes and protocols that you're running. But warning, warning, warning. When you run the debug command, it slows down your switch and your router. Slows down, and your network gets slows down. So be careful when you run this, okay? In order to ensure that you get all the log messages in your debug, okay, you have to give the command terminal monitor, okay? And then enable that so that when you do a debug or no debug, you can see the result. Let's look at some scenarios where we troubleshoot, okay? Sometimes certain devices in your network are configured to work on duplex, and certain devices are configured to work on half duplex. So some are full duplex, some are half duplex. The network still works, but it is not at its optimal performance. So fix it. Okay, so that could be an issue. Another issue is the IP version 4 assignment are manual, and some devices are waiting for DHCP IP addresses. So that could also be an issue. To be on the safe side, make sure you configure your router as a DHCP server, okay? And nobody is allowed to manually give an IP address. The moment somebody gives a manual IP address to the network, immediately cut him off from the network, okay? Some Windows-based machines, if they don't get an IP address, what they do is they follow something called APIPA, okay, Automatic Private IP Address. They give this IP address, 169.254.0.0/16, automatically. But when that happens, if you're on a subnet and your subnet is on a different network, definitely the Windows cannot communicate with that device, okay? So you should be aware of this. Certain things that certain operating systems do, and you have to switch off this capability on those systems, okay? Another thing you should know is your default gateway. What is the IP address? Have you given that IP address on your devices? Otherwise, you won't be able to communicate, okay? You can see one of the lab exercises, which is not a compulsory lab, but please have a look, lab 17. What happens is one of the computers, the devices, we take away the default gateway address. So definitely when you don't have a default gateway address, the computer cannot communicate, cannot ping, okay? So you have to be able to troubleshoot these small things. Also, DNS. Sometimes the DNS may give you an issue. So try and understand what kind of DNS server you're using in your enterprise. What is the hierarchy? And what are the issues? Okay. You can run your ipconfig/all to verify your DNS server. NSLookup will also verify your DNS. We'll give you information about the DNS that you have, and you can troubleshoot. That brings us to the end of this session, okay? And actually to the end of our CCNA-1. Anyone has any questions with regards to chapter 17? Okay, now let me